I'm Rob Smets, business lead at uWare Robotics, and we are taking the aerial drone revolution underwater to protect our oceans and secure our future. If you look at the blue economy, it's rated at $2.5 trillion, and it will grow faster than the general economy, solving massive challenges in renewable energy and food production. It also draws its life from the ocean, which occupies 70% of the Earth's surface, but it's threatened by climate change, pollution, and biodiversity loss. By UN directive, we should protect 30% by 2030. The Mediterranean is now really at 0.5. And to solve this dichotomy, we need data and underwater infrastructure and marine conservation. But current solutions to get this data are lacking. We have developed the first autonomous underwater drone, really mirroring the capabilities of aerial drones in terms of cost effectiveness and ease of use. It is uniquely combined with its own data processing platform. Compared to a team of scientific divers, one drone will be 3 times faster than 2 divers in their 50-minute dive time. It will collect more types of data in a more granular manner, and the data will immediately be ready for post-processing, needing no human to spend days going through it. It's not restricted to human dive times, so it can easily be underwater for more than 2 hours, just needing a quick battery switch before getting back to work. And with no human in the water, this vastly increases safety. Compared to remotely controlled robotics, there is an operator, vastly reducing the cost of operations. And this is not just our point of view. We have a letter of intent with Fraunhofer Smart Ocean Technologies to start using our drones to replace their retiring diving team in the monitoring of their artificial coral reef. We're putting an MOU in place with the Oceanographic Institute of Spain to work together on the standardization of ecosystem monitoring. While they could only monitor this line at the edge of the seagrass patch with scientific divers, or they spend days trying to get the full area in terms of pictures or remotely controlled robotics, even more days trying to stitch the map together, which in the end they couldn't. We came in with our drone, and in about 1 hour we mapped the full area. A couple of hours later, the fully detailed map was available, and right now we can map about 10,000 square meters or 1 hectare in a day. Let's look at an environment meets industry use case. More than 50% of the world's population lives within 100 kilometers of a coastline, and all that wastewater needs to be dispersed safely past these vital ecosystems. As you can see, a breach in the infrastructure integrity has massive effects on the seagrass patch around it. In under 1 month, we developed a use case to go down, find the pipe, track the pipe, and model it, vastly increasing the efficiency and the scale of the inspections. We are a European startup using our strong engineering fundamentals to make underwater data collection easy for the blue economy. And right now, we're looking for project partners to implement our existing solutions, to work together to rapidly develop new pilot cases, and we're looking for funding partners to enable the industrialization of our first product, and to enhance the development of new pilot cases towards new applications at a current funding need of 5 million euros. Thank you. I think questions are later. So
much. You'll come back for the Q&A, of course. And for now, we can welcome the second pitcher, V2O Marine. Let's welcome Rémi Alain. Rémi, it's your turn. Yes, thank you.
Thank you. I'm Rémi Alain. I am the founder of V2O Marine. So we develop and commercialize floating devices towed by ship, which continuously gather all types of floating waste in order to maximize their recovery. So there are pollution control vessels all over the world, and these vessels have small openings, no more than 4 meters wide for various physical reasons. And the question is how to increase the width, how to increase the efficiency of these cleaning ships. So at V2O, we have developed and patented a funnel-shaped gathering solution which can sweep up to 60 meters wide. So this solution can be towed by only 1 ship and makes it possible to work continuously without being conditioned on the filling of a trawl. And this solution benefits from a hydrodynamic convex shape, reducing consumption of traction vessel energy. So here is a picture of the system at 15 kilometers per hour. So we are traveling between 2 polluted zones. And here is a picture of the system in operation, where the system is opened There we walk at 4 knots, so 7 kilometers per hour, which is quite fast. So here are some clients we target. So Navy, shipyards, oil companies, service companies. Our goal is to go from this kind of picture to this kind much more fast than we do now. Because marine pollution is big, we need big devices to tackle it. Thank you.
Thank you so much. Thank you so much. There you go. And the third one is Planctonid Atlantic. Let's welcome Stefan. Stefan, it's your turn.
Thank you, everyone. I'm Stefan Ganassia, managing Planctonid Atlantic. And our story began 3 years ago. We won an RFP with a leading company called Yara in Saint-Nazaire Airport port. And today I'm here to say to you that we are cleaning every day with microalgae, industrial wastewater. We are providing a circular, positive business model, and I need your help to scale up. Okay, so if the ocean die, we die. So the raison d'être is to capture nitrogen and phosphorus before to get it into water, obviously, and to avoid dead zone expansion. So we are leveraging and developing biotechnology that have been awarded in the COP25 as the best startup in Europe for waters. And here we are. This is our plans. I want to show you how we invest 3 million. I want to show you the way we work. If the video can be launched, I don't know. If not, the time is running. So this is in Saint-Nazaire. This is Yara plants, so fertilizer plants. And we get some waters of Yara in our laboratory. We got more than 20 species specialized in water treatment. We capture phosphorus, we capture nitrogen through our unit of microalgae bioremediations. Okay? And from these units, then we do 2 things. We get clean water and get back clean water to the industrial. And we have obviously biomass, and this biomass that you can see there, we transform it to biostimulant or biofertilizer. And as our partner is Yara, we will come to their industrial advantage to break through the market. Okay, so moving from mineral to organic biostimulant. So you understood that we leverage photosynthesis process, capturing O2 and cleaning water. What we need is that we need to put the first module of reference. It's a kind of Lego plug-and-play game. So we got one on 6 stages to win a space, and then we duplicate 40 times this. Okay? This is a challenge. You understood this is circular economy, 2 ways of revenue, water treatment and biostimulation. And last but not the least, because of Yara, we tackle this market with an industrial advantage. I won't talk about the team because I won't have time, but I want you to join us to protect oceans and avoiding dead zone. Thank you.
Thank you. Here we go. And the next one is Kusini Water. So please welcome Murandini Mafumo. Welcome, Murandini. You're good.
Hello, everyone. My name is Murandini. I am a water scientist by training, so I've got about 14 years working in the water and sanitation space. I used to work in the public sector in South Africa, city of Cape Town, as well as Johannesburg Water. Yeah, in Africa, I mean, globally, about 1 billion people lack access to safe drinking water. In Africa alone, every 90 seconds, 4 babies die due to being exposed to unsafe drinking water. I come from Limpopo as a person that every single day where I come from, water is a story, water is a conversation, water is a journey. So when I started my career as a chemist, I made it my choice, I made it my mission to do something about it. But I started working in the city and the municipalities for some time. Right now, I run an organization called Kusini Water. Oh, this is going forward. Yeah, so at Kusini Water, we make water filtration systems for two sets of people. So one is communities that do not have any pipe network of water. We use locally sourced macadamia nut shells, which is waste material we get from farmers locally. For every system that we build in the continent, for every system that we build for communities, we plant a macadamia tree within Limpopo, which consumes a couple tons of carbon dioxide. At the same time, we serve a second market. This is a market that uses a lot of water within the African continent. We ensure that when they are operating, be it in the building or wherever, they've got access to good quality drinking water. So our main strategies really is one, we're decentralized water companies. Secondly, we use locally sourced material. We've got 4 patents that we've got in low pressure water systems. And all of our systems either use renewable energy or are gravity fed. And all of them have about close to 5 sensors per system that just allows us to do both preventative maintenance as well as remote monitoring. Oh, I'm going backwards. That's forward. Yeah, so I've already spoken a lot about the problem. Our main solutions really is 2 products. So one is the water box. This is a mobile, again, decentralized water box. It takes any water source, it converts it into drinking water, and then we'll put a localized water reticulation system for that community. So imagine a mine, imagine a remote village, refugee camp, or a disaster hit area. This is where we use that system. Second one, much larger system. Okay, I have to breathe. Much larger system, which does about 20,000 to 40,000 cubes of water, primarily for large users of water. And again, we've got an IoT system that attaches to it. And the biggest thing for us right now is that we've been, over the last couple of years, created a lot of traction. Right now, we work with a few French companies. For example, we were working with Air France and KLM for their African program, both for their onboard water as well as their community water. Right now, we're doing close to 20 million liters of water every day. We're growing every year for the past 3 years. We're serving close to 125,000 people on a daily basis. And we are looking right now to raise 1.2 million euros. Majority of that money is to allow us to scale into the rest of the African continent, improve our sourcing material. So we're going to get more farmers to join into our supply chain, have more macadamia trees, as well as increase our fleet and working capital. Thank you.
Thank you. Thank you for your product, Kusini Water. Thank you so much. And we're going to welcome, last but not least, Origin by Ocean. Let's welcome Mary Granstrom.
Thank you very much. Thank you. It's awful to be the last one, but try to hang on there. So my name is Mari Granström. I'm the CEO and the founder of Origin by Ocean. Our purpose is very simple. We want to make the chemical industry run on algae. So instead of using naphtha crude oil, we want to use algae, and we want to be in the same value chain. So we want to produce better products from algae, what we are doing today from oil. So we are tackling 2 problems. One is the high dependency of oil we have as a society. So we don't normally think how much oil we have accumulated as consumers in our everyday lives. And this is where our products come in, and they actually substitute these oil-based products and ingredients what we use today. Second one, eutrophication. We have excess of nutrients in the oceans, in lakes, in rivers, in all the water bodies of this world. What happens is that when you reach the tipping point, you go over the tipping point with the concentration of nutrients, you start to see algae blooms. And what happens? What do you do with algae blooms? We take them out when we actually use them as a feedstock. So when we do that, we also remove the nutrients from the oceans. So our biorefinery technology is really turning this problem into algae-based functional ingredients, and then when they go to the consumer goods, they actually decarbonize the products as well. Here are our products. So we follow the golden rule of biorefinery, where you have to squeeze as much as value as you can out from a single feedstock. And hence we have all of these different functional products. No additives, high functionality. And they actually go all the markets, from textiles to cosmetics to hygiene to food. So we can tap to very different markets with all of these products what we are producing today. We are regenerative, so we are more than being sustainable. Regenerative business means that you have to leave a net positive impact in both sides. So when we take the seaweed out, we remove the nutrients, we actually leave a net positive impact into the marine ecosystem. We do the same in a consumer and a market side. So when we decarbonize, we actually take a heavy carbon out from the consumer goods. And again, we leave a net positive impact behind. Our biorefinery technology is in the middle, so that's the key, and that's how we call it, as an enabler to make this whole thing to happen. We have a co-branding business model, which is of course very different what you see today from the big chemical players. You don't see BASF, you don't see Dow or DuPont in any of the consumer goods. There is a good reason for it, but we want to be there. And this means that, of course, our customers will have a differentiation model in their products, because we will give them all this impact, which is not greenwashing, but it's all calculated, analyzed, and measured. Thank you.
Thank you so much. You can stay on stage, and I'm going to invite the last 5 pitchers to come and join us for the last Q&A of this round. I invite all the jury members to ask at least one question to each pitcher. Whenever you're ready.
Fellow South African, Kusini. I must ask you, I love what you're doing, cleaning water. That sounds like a fabulous product. What I didn't quite catch was, what is the business model and who are you selling to?
Yeah, so the business model is essentially 2. So we work with corporates for CSI. So the biggest chunk right now is CSI income, and then CSI as well as enterprise and supply development income. But the second one, which is more exciting and more interesting, is when we set up the decentralized systems, we set them up with income generating capabilities. So we partner both with local government as well as tribal leaders to generate income from those facilities. So we make a couple of cents per liter produced. So the community needs to pay so that they can feel like they own this thing, and then also they can ensure that we can sustain it. We make a couple of cents, and we're projecting that 70% of our income by 2027 will be coming from that. We'll be collecting something closer to 40 million just from that.
Thank you very much.
I have a question still for you, Kusini. I didn't get clearly the tech aspect and how the macadamia nutshell comes into the equation.
Yes. So our patents, we've got 4 patents. So one is a combination of macadamia as carbon with a nanofiber membrane. So the membrane that we're developing is a polyvinyl membrane. So we're just changing the input material on the vinyl, on the polyvinyl material. So the macadamia is for carbon, the combination of carbon with a polyvinyl membrane material. That's where our one patent is on. And then the process as well, the combination of process as well, we've patented that as well.
Thank you very much. Let's switch to other projects.
I have a question for Rob. Good presentation, very promising to talk about robotics. Can you talk a little bit about how you differentiate on the market? Because there are quite a lot of robotics companies out there trying to propose very similar type of offers. How do you differentiate in the market?
Well, that's indeed something that's it's very strange listening to myself. Depends on how you look, because the underwater robotics market is very big, going from these very big ROVs to smaller systems. You have indeed small, affordable ROV systems. I think there the differentiation is clear. And then you have some autonomous underwater vehicles that are starting to emerge on the market, also in an affordable scale. Again, according to the torpedo range, which is good to move on a larger area, but it's not good to move highly detailed in a smaller area like a team of divers would do. The differentiation is also clear. And then we see a couple of emerging players worldwide in Australia and the US. Indeed, where I think we would have to speak more in detail, because that's really talking about engineering specifics and what makes the difference. In terms of differentiation, I know that the players we're talking with in Europe are not working with those solutions yet for environmental monitoring, for ecosystem monitoring. It's not working for what they're doing specifically. So depending on what you're looking for, underwater robotics is more niche than aerial robotics. I think there's something to find for all these players, but I'm not going to list all of them. That will take us too far.
Thank you very much.
I have a question for Origin for Ocean. How do you organize the seaweed supply?
Yeah, so that's one of the most important thing is to basically build the supply chain. So that's what we want to use the local partners. So for example, in the Caribbean, where you have 25 million tons of sargassum blooming every year, we want to empower the locals to do the harvesting and the logistics for us. So we are the biorefinery people. We want to run the biorefinery, and we really want to make a business of harvesting to other parties, which are already existing.
Thank you very much.
I have a question for you. How can you manage to not catch too much fish in your filet?
Yes, it depends on the speed you go. If you go at the maximum speed I've talked about, so around 2 meters per second, so 4 knots, it can be a bit dangerous for the fish. So we have thought about a system, if we have a net behind, to make the fish escape. But during the test, we noticed that there is more danger considering a speed of 5 knots. At 4 knots, it's quite enough for them to have the capability to go out. It's yeah.
I'll take on this
Wonderful.
side. So really enjoyed your presentation. Could you explain a little bit about how it scales and how it endures? So in my head, I've got you seeing a lake that needs to be dealt with. You build your system. How long does it take to repair the lake? Do you have to stay? You know, how do you scale in that sense?
I'm not sure to get your question, but I will try to answer. What we have now is we need to build the first models. First models is 800 photobioreactors, and this is a kind of Lego. Once you do once, then you just duplicate it. Did I answer?
Do you need to be in the location where the water needs repairing in that sense?
Yes, unless you want to transport the water, but I don't think from an eco responsibility it would be fine. So yes, I think we need to.
Yeah, thank you.
Thank you very much for your questions, jury. Thank you very much for your pitches. You will have time to discuss more in the networking area. Thank you so much.